Welcome to Study Loop.
So for part A, the time for one revolution is the circumference of the orbit divided by the speed v of the sun. So we can say that the period would be equal to 2 pi r, simply the circumference, divided by the speed v, where r is, of course, the radius of orbit. We know that r would be equal to 2.3 times 10 to the fourth light years, and there are 9.46 times 10 to the 12 kilometers for every 1 light year. Therefore, the radius is going to be equal to 2.18 times 10 to the 17th kilometers. And we can then say that the period would be equal to 2 pi times 2.18 times 10 to the 17th kilometers divided by 250 kilometers per second. This is giving us a period of 5.5 times 10 to the 15th seconds. So this would be your answer for part A, the period of the sun. And we can say that for part B, the number of revolutions n is, of course, the total time t divided by the time capital T, or the period, for one revolution. So the number of revolutions would be equal to t divided by the period. So we can then say this would be equal to 4.5 times 10 to the 9th years. There are 3.16 times 10 to the 7th seconds per year. And then we're going to divide it by the period that we had just found in part A of 5.5 times 10 to the 15th seconds. And we find that n is equaling 26 revolutions. This would be our final answer for part B. That is the end of the solution. Thank you for watching.